Hello everyone, welcome to the second video of my channel. So today we will talk about the big Mart sales prediction of analytics Vidya, which was a practice problem and around 47,000 people registered in it. So you can see that this hackathon is ending in 91 days, but it is not like that. It started from 2016 and it is still running. So what they does is they reset the timeline after every 6 months. Okay, so as it is a practice hackathon and the score is calculated in the public score only, not the private score, so it is not possible to check our actual rank. But what we can do is probably we can try to get a solution of top 1%, and that should be sufficient to solve the business problem. But in terms of chasing the top few ranks, probably it is not the right hackathon to do so because there is no way you can check your actual rank. So you can download the data from this problem statement after you registered in the hackathon. Once you scroll down to the page, you can see that there is the option to download the data. And also the data dictionary is available that I will explain in the video also. But as the hackathon is still running and will continue to run, this will be available all the time. Okay, so first I load the data and I can see that there are 8,500 observation in the training set and around 5,600 in the test set. So this is a probably small to medium size data, and I will first check all the columns and its data type. Okay, so first I just write the train.head, then train.info, and I can see there are two columns where there are null value present. One is the outlet size and one is the item weight. Probably we have to look about it. And also I can see there are object type columns like item identifier, item fat content, then item type, then outlet size, outlet location type, and outlet type. And then we have the target of item outlet sales. Okay, now for the univariate analysis, we know that there is the package suite which probably if you uncomment this line and run this particular code, this kind of HTML report will appear. And now we'll check all the columns and note our findings. And for the description of the column, probably you can pause the video or go to their site and check the details. But just for your brief understanding, this item identifier is the unique product ID, and this outlet identifier is the unique store ID. And what we have this in the testing data is we have one column of this item identifier, one column is the outlet identifier, and we have to predict the sale, and the evaluation metric is root mean square error. Okay, so this is the target the root the we need to predict, and the evaluation will be done on that. Now going to the report again. So we can see there are almost 1559 distinct values, and it is difficult to fit this much unique values in the model. But what we can observe is that if we carefully look about the first two character of this identifier, there are only three different types of value present. That is FD, then NC, and DR. Okay, and probably we can that is a important thing to observe, and probably we can just substring this particular identifier and treat it as a new column. Then is the item weight. So this is a numeric column. Probably we will check the distribution of it later. And then the item fat content, so we can see there are five unique values, but actually it can be converted in the boolean column because this low fat in proper case and lower case and lf are same thing, and also regular and reg are the same thing, so we can convert it into 1 and 0. Then we have this item visibility. This is also seeming a numeric column, but what is suspicious is that there are so many zeros present, and we from the business understanding we can know that it is not possible to have item visibility 0, and that is also the definition is given here. So probably we can treat it as a missing value, and other just like the other missing value, we can take care of it. Then we have item types. So there are the different types of item, and like there are few drinkable item, few food item, and few not eatable item. And what we saw in the earlier section is that we have this fast true ID like FD, NC, and DR. And what I noticed that this particular this particular item has only similar first two digit of each type, and probably the FD means food item, the NC means non-consumable item, and DR is the drinkable item. That I also explored separately. I am not going to show you in the notebook to save the spaces. Now I am going back to the rest of the columns again. So then we have this item MRP. So it is difficult to observe this much of unique data in this wide histograms, but probably we can check about in the scatter plot later. Then we have the outlet identifier. This is the unique identity of each of the outlet and can be treated as a categorical column. Then we have outlet establishment here. So probably we can drop this because what we saw that there are 10 different outlets, and we have 9 outlet establishment here. So almost every year has a one particular outlet, and only one year has two outlet only. So that will not going us to give any additional information, and we can drop it. Then we have outlet size. So it is medium, small, and high. We can probably convert it into 0, 1, 2, or 1, 2, 3, but that is depending on the performance on the target. Then we have this outlet location type, same like the previous one. We can convert it into the 1, 2, 3 after checking the effect on the target. Then we have this outlet type, so we can see the one have the grocery store, and the rest of the three categories are different kind of supermarket. But what we observing is that supermarket type 1 is probably the most common one. But we cannot do much in here because probably we can keep it as a single categorical column only. Then we have this item outlet cell. So it is also a skewed data, but I tried log transform here also, but I saw that the normal outlet cells is performing better than the log transform. So I decided to keep the original one. Okay, then I run this for loop to note down all the unique values and the missing values for my easy to use in the later stage. Then I am going to do the target analysis. First, for the numeric categorical column, I am using this violin plot. So for this item type, there is nothing much interesting here, but in the outlet type we can see that this outlet 10 and outlet 19 are far different from the other rest of the outlet. And what I also observed that these two are actually the grocery stores. Okay, and then we can see that this outlet size is medium, high, and small, but we cannot convert it to the 0, 1, and 2 because this is not monotonously increasing in performance. Like after small, the second base is high and the best is the medium. So if the medium was in the middle, probably we can convert it to into 0, 1, and 2, but currently we cannot do that. And then I am use the scatter plot to observe the item MRP. And what I interestingly found that there are gaps in these four different kind of groups, and other than this item memory, probably I can separate them in four different categories. Then I am plotting this item visibility. As I mentioned that there are so much zero present, probably this can be treated as a missing value. And also I can see there is some drastical change in the pattern after 0.19. Probably we can add a separate boolean column by separating this observation greater than 0.19 and less than 0.19. Then we also plotted the item weight, but there is nothing interesting in the data, so we are not going to do anything here. Now to fill the, just because there is nothing interesting present in this item weight, I am just using this filling with mean, filling the missing value with mean method. But what you probably can do is another option I am giving it to you, that you can probably summarize the entire data by item identifier and take the sum of the is take the mean of the rest of the item weight where there is no missing value, and probably you can use a left join to merge, add this. But currently I am going to fill with mean only, because I don't think item weight is going to be a major factor in this problem. Okay, then I am coming to the data processing and feature engineering part. So first, as I mentioned, that the item fat content can be converted to the Boolean column only. So for regular and reg, I am replacing with 1, and the rest of the things I am replacing with 0. Then for the item visibility, first I am converting the zeros to missing value, that is the NaN. Then I am converting into the float. Okay, then for the item identifier, as I mentioned, that I am substring the first two character only for food item, the drinkable item, and the non-consumable items. Then I have created a new feature named running from this establishment year, because it was mentioned the data is from 2013 in the in the problem statement, and I just subtracted the outlet establishment year and can be used as a numeric column. Okay, then we have the, I created another new column that is price per weight. So it is just the division by in item MRP and the item weight, and that is nothing but the MRP per weight. And probably that can be a important factor, because there are so many food items are present, and sometimes happens that you buy the food by kg and does not buy by a particular quantity. Okay, then I have done something interesting. So we observed that the outlet size is has few missing values, and what I observed that this outlet 10, outlet 17, and outlet 45, only these three outlets have all the missing data, and none of the outlets has any kind of missing data. But from the violin plot, I saw that this outlet 10 is pretty much similar to the outlet 19, and that is the small store, and this outlet 17 and 45 are similar like a medium store. So I replaced the outlet 10 with a small, and this outlet 17 45 with medium. Then I created another new column of, I named it as MRP2. So is that is nothing but I separated this particular items in the group of the MRP in four different groups. So I took the some intermediate value, and that is also pretty much obvious that the as there is a few missing values present, so it is good, probably it is a better way to um, classify is in different group rather than treat as a pure numeric column. And anyway, we are not going to drop this MRP. We are keeping them both, and we will rely on the model to take care of it. Okay, then I am doing similar with the testing data also. Here that I mentioned that this item visibility you can try a Boolean flag, but what I noticed that this is actually reducing my performance, so I dropped it. But that is also you can use for any other kind of problems. But here I am not going to use it. Okay, now then I am just checking the correlation with the target for these few numeric columns, and what I noticed that this item MRP and price per weight has a very good correlation, and this item visibility also has a pretty much good negative correlation also. And it is pretty much obvious from the plot. You can see that item visibility has some negative correlation with these outlet cells. Okay, now here is our final feature and the level set. I just dropped the item outlet sales and outlet establishment here in my feature set, and I just separated these train outlet cells for my label. This is my final data frame, how it is looking like. You can see that this item identifier now has only two characters, and this item type, then item outlet identifier, outlet size, outlet location type, outlet type, these are the categorical column. And if you check this xtrain.head, you will see that the two columns that I dropped here are also missing. Now, for this particular problem, I have found this catboost model is performing best, and here I have used Optuna to tune my hyperparameters. So, if you are not aware of this Optuna, so it is a nice way to automate hyperparameter tuning. Probably you can just copy my code that will be available in the description of this video, and and try different ranges of the hyperparameters. Just for the demonstration purpose, I have used a smaller set and very small estimators. And also, I have just ran this particular trial for 5 times. And after ran this trial, I found these are my best set of parameters. But if you are participating in a hackathon and if you have time, probably you should try with a wide range of parameters, a higher estimators, and probably higher number of trials. But for this particular problem, I found this is already a good enough to give you a 1% rank and top 1% rank, and probably even better. And currently, I have in other time I tuned it in much finer way, and here I am currently in the 29th rank. So you can see that this is I am currently in the 29th rank. But as I mentioned that you probably should not waste much more time here, because there is no point to get top rank unless this is a private leaderboard. Anyone can do some hack or overfit the data to get a higher rank. Okay, so after this running this base setup or parameters, I am I am get the prediction. And what I did is here that there are few values that are less than zero and maybe closer to zero, and as a food item that should not be less than zero, or probably it is almost impossible to very closer to zero. So I have converted all the value less than 33 to the 33, because what I saw in my universal statistics is that the minimum value is 33. So I just used it as a benchmark, and if it is something less than 33, it is not going to impact my performance much more. But I cannot do it for the maximum value, because then then if there is a difference in 100, so that is that is a very small difference for the higher prices, but that can affect my total score a lot more. So after doing this particular changes, I am ready to submit my score in the analytics with the. And for this particular subset of the hyperparameters, I got a score of this 1146. But as I mentioned that if you train for a really long time, probably you can get score of 29 that I achieved, and probably even better also. Okay, so that's it for the video. I hope you enjoyed this video. If you have any doubt, you can reach to me by mail or by LinkedIn, and I will keep continue uploading this kind of hackathon videos and different useful machine learning videos in future. So if you find this video helpful, probably you can subscribe my channel. Thank you so much.